get into the big topic of open source, something that we actually say.
This is so awesome.
We are an open culture that
it's actually a big piece
What is that process that a developer, or let's say,
as the Kubernetes ecosystem really boomed?
All right, and we are live. Welcome, everyone, to another episode of GitOps Guide to the Galaxy. I will be your captain in this journey, Christian Hernandez here, technical marketing at Red Hat. And my co-captain today is, should be pointing the right, a very special guest here. I should point to that. It's always mirrored, so I'm not sure here. Is I have Rosemary here from HashiCorp to talk to us about Vault. So Rosemary, real quick, kind of give us tell us who you are here and, how you're going to be helping us co-captaining today.
Yeah, I'm here to help you navigate the terrifying waters of secrets management, aka how do you not accidentally show your password to everybody. So I'm a developer advocate at HashiCorp. I've worked quite a bit in various roles, networking, cloud, other. I've been working on a book about infrastructure as code. So pretty much defined my career as a jack of all trades and master of absolutely none of them. But it's been a really fun experience, and secrets management happened to be a very interesting, near and dear topic to me because I was that unfortunate soul who accidentally exposed.
Oh no. No, that's well, it's good that it's one of those things that you learn from your mistakes, right? And then you become a really good advocate. I think the best advocates are the ones who've made the mistake before, right? Because you're always, I've been in your shoes before. So again, very excited to have Rosemary on. It's been, I've the question I constantly get asked all the time is about secrets and GitOps. And since it's a GitOps show here, it's like a topic that always comes up. Like, I was not sure if you were here at KubeCon when it was here in LA, but people were constantly doing hallway things in the hallway track sort of things, where they were telling, they were asking me, okay, love the stream. So secrets management, and then it'd be the first thing. I'm pretty sure. I guess besides Terraform, Vault is probably really popular over at HashiCorp, I would imagine.
Yes. So HashiCorp Vault is a secrets manager. It's really unique. It's a lot of fun to work with. And in some ways, it's a complicated tool, but it makes secrets easier in other ways, right? Because secrets management breaks infrastructure as code. It breaks immutability.
Mm-hmm.
And in many ways, it breaks GitOps, right? Because you're using a mutable approach. You're treating secrets mutably when you rotate them dynamically. And that breaks sort of this declarative infrastructure as code immutable approach. And so it's a really interesting tension between the two. But the whole purpose of Vault is basically to store, manage these secrets, secure them, but also rotate them for you and revoke them according to the rules that you set.
Yeah. Oh, that's we're already getting deep into the weeds here, but yeah, it's definitely a big topic, right? It's definitely a big topic, always discussed, and it's always a popular topic, especially with GitOps. I'm deep in the GitOps world, and it's always something that we're constantly talking about. Just constantly, even if you covered it before, people just keep asking, and it's constantly going on here. So before I kind of hand the reins over to Rosemary. I do want to go over a couple of things real quick. One is the CFP for GitOpsCon is still open. I put the link there in the chat, so go ahead and drop in the chat. It's open until Valentine's Day. Actually, it's the last day. So CFP closes in a couple weeks. The being part of the program committee, I can tell you is that we're going to have 2 tracks this time around. So more of a chance for your talk to be submitted. So please feel free to submit a talk. Rosemary, maybe you can submit a talk. Maybe I'll see you there in Spain. Who knows, right? Secret management. I'm pretty sure there'll be a ton of people in that talk if you decide to do that. So again, GitOpsCon. This is going to be our 3rd one. So crazy how fast this has grown. CFP still open. Check that out. And also, another thing is that yesterday, it feels like last week. It's just these weeks have been
What is
running into
time?
each other. Yeah, what is time? Who knows? Waleed, yeah, Waleed asked. By the way, Waleed's one of our regular viewers here. He asked, "Does this mean are you coming to Spain?" Actually, yes, I am coming to Spain. So being part of the program committee and being part of Red Hat, I'll be there for KubeCon and for this Day Zero event. So Waleed, if you're gonna make the trip to Spain, I'll be there. So maybe you can show the cool socks we sent you that one time. We did a release yesterday of OpenShift GitOps. So I put the link there, the link again in the chat. Just kind of some of the features. We upgraded to Argo version 2.2.2, right? 2.2. We upgraded to the Helm version 3.7.1. And also, I think the biggest thing is that Argo CD has added the, OpenShift GitOps has added health status for deployment configs, routes, and OLM operators. So before the health status was kind of really generic. Now it's really bit more specific. So you can go ahead and check that out. So I know we have a big topic to cover. I know Rosemary said that we'll need about an hour, and we'll probably go over. So, so without I guess further ado, I'll hand the reins over to Rosemary to start. And if you have any questions, feel free to drop it in the chat. I'll send them over, and I'll step back here because really everyone now is just waiting to hear about and talk about Vault. So go ahead.
Oh, it's so popular. It's like when
it's so popular.
Joke, yeah, with one of my teammates, the joke is like the cat's more popular. It's like Vault is the cat, right?
Yeah, exactly.
Everybody gets really excited for it.
Yeah, definitely.
Yeah, so I guess it's a 2-part series because I told Christian that it's a lot to talk about Vault. And if you don't or you haven't used Vault before, there are a lot of concepts and a lot of terms. My goal is that hopefully by the end of this, you look at some of these terms and they're a little bit less intimidating. You're at least going to identify the workflow, right? So if you're using Vault in your OpenShift cluster or you're using Vault for anything else, at the very least, you're not muddled by all of the concepts and the terms that come with working with Vault on Kubernetes. Just as a note, Vault is a secrets manager. It stores sensitive information. You can choose not to deploy Vault on Kubernetes if you want, right? Some folks choose from a security perspective to deploy it separately. You can still connect to a Vault server and retrieve secrets, but it's just not in a Kubernetes cluster. Today, I will show it in a Kubernetes cluster. It will run in its own namespace, but there are ways that you can set up Vault that are outside of the Kubernetes cluster as well. And you can still connect to it from Kubernetes. So there's a caveat to all of that. I won't go too far into Vault architecture, but there's 2 pieces to Vault's architecture. The first is a Vault server, and then it's the Vault clients, right? So Vault server is the control plane. It houses all of the secrets. It manages and stores and encrypts any of the secrets. And you'll see some of that today as I deploy it on Kubernetes. There are also clients and agents. The clients and agents read information about specific secrets so that you can proxy it to an application. So there are no slides. I will show them. But for now, we're going to just leave it at that because it's a lot easier to understand it when you work with it and you get hands-on with it. So I will start. Oh, go ahead.
Sorry. And then there's also a pretty good question here is about and I'm not sure if you're going to go over this, but what the pros and cons of having it external versus internal, outside of a Kubernetes cluster versus having it internal, I'm pretty sure there's pros and cons, but are you going to kind of go over, what those are?
I wasn't going to go do that, but I can certainly answer that now. I think it's a great question. So there are certain reasons why folks don't want to run it in Kubernetes, for example, right? They want to isolate this onto a certain, subset of machines. From a multi-tenancy perspective, they want to make sure they lock it down. Vault has a couple different storage options, right? So when Vault has that information, has secrets, has configuration, it needs to store it somewhere. And so that storage mechanism, that storage backend can differ depending on how you set it up. And so some folks who don't necessarily want to run it on Kubernetes because, well, in Kubernetes, we run it as integrated storage. Perhaps they want to use something else as a backend. They could use HashiCorp Console as a backend. They can use some other database. So for those who don't want to necessarily run it as an integrated storage option, they choose to run it outside of the Kubernetes cluster, something very predictable from a virtual machine option that they're used to managing. Other times, they're trying to proxy secrets that are not related to Kubernetes, right? So in an environment that doesn't always involve a Kubernetes cluster, you might choose to manage the secrets for many other things. Databases, for example, we'll show that today, but you can manage database secrets using Vault, and that doesn't necessarily run in Kubernetes either. So you need some other endpoint for those databases to be able to access that. So there are a couple of reasons why you would run it external from an access point as well as a security point, depends on your posture. Now, as to why you would run it internal, it's pretty easy to install it on Kubernetes. There's a little bit of friction in terms of upgrade and management, but if you're familiar with Kubernetes and you're familiar with managing and upgrading some stateful components that you're deploying onto your Kubernetes cluster, the pattern is there for you. And it's a little bit easier for you to manage because you're familiar with that kind of approach on Kubernetes, right? So there are pros and cons to both. There is a link. I will try to get that to you when I have more windows and I can find the link to you that describes it in far more detail and some of the considerations from a security and a storage perspective, as well as from a Kubernetes perspective as well.
Yeah, I think a lot of I think you have to keep in mind that Vault is a secret management platform almost, right? Independent of Kubernetes. So you can use it with Kubernetes, but you can also use it for everything else in your environment. So I think that's where I know in the way in the beginning, I'm showing kind of my ignorance. I thought it was like a Kubernetes specific thing. And as I read more about it, it's like, oh no, this is just like just generic. Like, if you have a secret management system, you're going to want to use it, for your entire enterprise. So, so that's kind of something else to keep in mind. Am I using this for Kubernetes? I think that's maybe another consideration. Am I using this specifically for Kubernetes? Am I just going to use it in general in my environment? I'm pretty sure other regulatory things come into place. So I think it's the pros and cons are probably more political than anything else, I would imagine.
Yeah, and I think it's also a couple folks want secrets management on edge, right? On edge computing as well. So you can't run anything process heavy, right, on edge networks or edge computing. So the result is that it makes a lot of sense to say, let me run the server somewhere else, and then on the edge, if you are using Kubernetes on the edge, I just run the clients and access the information from Vault, right? So there are some complexities to that I will not go through because replication is a whole, replication is like a whole rabbit hole. So I won't go through that.
I always say crawl, walk, run, right? Yeah, first, it's just kind of get the basics going on first.
Exactly. Yeah. So in this situation, I will be deploying Vault, the server, and the entire platform, and it's self-contained on Kubernetes. So keep that in mind. Some of the things that you'll see today, I'll show some of the secure way to do it, but it's not going to be everything you can do to secure Vault on Kubernetes either. So keep that in mind.
Cool. Perfect.
All right. So I'm going to start sharing my screen, and hopefully you'll be able to see
let's cross our fingers here.
Text. I know. No. Oh, the text. This is not helpful. Okay.
So I could kind of make out that you did get pods. So maybe if I start translating, it can help out.
Okay. Yes. Oh, yay. I don't know what is going on with this today. What I'm going to do is I'm going to send a live share to you, Christian. And if you open it up on your screen and you see that it's better, then maybe we try your screen share. And at least that way folks can see what's going on. Yeah. So I'll narrate while Christian tries to join the live share. So effectively what I've done is I'm using CRC, so it's all on my machine. This is not a live cluster, so we've reduced any network related activities. But I've created 2 namespaces. One is for Vault and one is for my application, which I fondly call expenses. It's an expense report API. It's not the most glamorous API, but it returns expenses that you log. And we're using that today because expenses is a Java application that retrieves information from MySQL. This is important because this is how we are going to integrate it. Okay, so the first thing we're going to do is deploy Vault. Vault has a couple different configurations, and this is going to be tough for folks to see. So, oh, yeah.
I'm still trying to join the live share.
Yeah.
Right now.
Let's see. All right. Yeah, get pod Vault. Okay. This is what happens when, let me try to switch screens. Hold on, everybody. I just want everybody to be able to see it at least. Let's see. Maybe that is better or worse. I can't tell. No, still the same.
There we go.
Oh, here we go.
Oh, it's doing something. Okay, I think I got it. I can share my screen if that helps.
Yeah.
Let me try that. So, where's play local video? Share screen. Okay, it's not as if I've done this before.
You know, this is like, I don't know what is going on. You know, we fiddled with the resolution. We thought it was a stream issue. Okay, all right. So there we are.
Make this a little bigger.
Yeah.
Let me close this right here.
Okay.
There we go.
All right. So let's see if I type.
Output.
It's terminal. Yeah. So
Okay,
let me see if I can. There you see.
There we go.
Okay. All right. So you can see my terminal now. Thank you, Christian. I appreciate that. All
yeah,
right.
no worries. Yeah, teamwork, right? We do this together.
Yeah, this is technology. If you could zoom in a little bit more.
Yeah, sure. Oops, I just zoomed in the wrong screen. I'm like, I thought I did. All right, so a little better. So, for those who are watching, is that better? Waleed says it looks better. Visibility achieved. All right, we got a badge, right?
Yay! Yeah, if you could bump the terminal next to the X on the terminal, if you could put the little arrow, press the little arrow. Yeah, that way it goes full screen terminal, and then let me just clear it that way.
There we go.
Okay, apparently it doesn't want to do that today. All right, that's fine. We're going to work with it.
That's right. Someone says that your plant game is on point. They're commenting on your greenery back there. So.
Yeah, they're all real. It is a jungle back there. There's what they don't see on screen is the flies. There are flies everywhere.
Okay.
All right. So the first thing we're going to do, as I mentioned before, I created 2 separate namespaces. One is for Vault and one will be for my application. You do probably want to put Vault in its own namespace. From a component view, there's not too many components to it, but then again, you want to make sure you're securing it and you're isolating it to a specific, specific namespace in Kubernetes. So the first thing we're going to do is, well, the very first thing, which is install Vault. Vault runs as a Helm chart, and so you can imagine that it's a Helm install. So I'm going to start the install, and that way we can have some of this up. But I'm just pinning the version of the Vault Helm chart as well, and we're going to deploy a couple of other things. So I'm just going to copy this command so you don't have to watch me type. But there's 2 things I'm going to be installing today, and the reason why I'm installing 2 things via Helm is that there's 2 different ways you can inject secrets into your Kubernetes applications. And so one is called the Vault agent. So if you deploy the Helm chart by default, that is actually the configuration it will support. So it will give you the Vault agent injector. It's using a mutating webhook to inject a sidecar into any application that needs the Vault agent. There's a second way that you can do it, which is called the Secret Store CSI driver. And what happens with the Secret Store CSI driver is that you don't have a sidecar agent. So you can imagine now we're going to have an architectural discussion about why you would have an agent versus one that you don't have an agent. So these are the two ways that you can deploy, or you can use Vault to inject secrets into your application.
So just to be clear, there's
Mhm.
there's two methods, is what you're saying.
Yes, there are
Okay.
two methods. I'll also get to the caveats of each method and why one may be preferable than the other. But just as a hint, one may not be as secure.
Okay, there you go.
There you go.
That's a big caveat.
Yeah, that's a big caveat. Okay, so at this point, I'm going to go back to files. So I think you can, if you could click the little drop by the terminal. Yeah,
right
there we
here.
go.
Okay.
Yeah, perfect. I don't know if you can follow along with me, but I'm going to open up Helm, and it will be vault.openshift.yaml under the Helm directory. Oh, there we are. You followed along. Okay. So you noticed I deployed Helm. I didn't really explain what exactly I was deploying. The first thing is that the Vault Helm chart does deploy on OpenShift. There are some OpenShift specific configurations. So naturally, one of the values you'll have to set is OpenShift true. So keep that in mind. There's also a couple of images that you can add as well. These are specific to the Red Hat registry. So this is pinning to Vault 1.9, and then there's a couple of injector images that you're going to require. Vault K8 is a special image. It's used to retrieve, do authentication and retrieve the secrets for your application, right? So keep in mind that a lot of the orchestration will come from the Vault K8 binary here, and then Vault itself, the Vault binary is needed so that it can actually retrieve, do API calls against Vault. So there's a couple images that you'll need. And then one thing that I set that is something unique to this particular values file is I'm setting HA enabled true. If you use the Helm chart, you have two options. You can set Vault in dev mode. Vault in dev mode is really useful for testing. You can bring it up and you can work on it, right? But it doesn't give you a good sense of how you operate Vault. There are some security measures that are disabled as part of the dev mode for Vault server. So as a result, I'm going to show you the non-disabled true production, not true production, but almost production configuration. So you actually understand the Vault operations aspect. It is only
as close to production we can get for a demo, right?
Exactly, because I only run it on one node, so I can only really deploy one replica.
Yeah.
So we're
Well,
deploying
I like it says
Yeah.
HA, but with one replica, you're like, wait.
Yeah, it's a bit of a misnomer. I was,
Yeah.
I was like, oh, maybe I'll just deploy a 3-node cluster and like really do true HA. And then I was like, the complexity there. We're going to remove the complexity of that, but it is a Vault server. It will run one instance. And the other thing that it will do is run integrated storage. So I mentioned before, Vault has a couple different storage backends that you can choose. The one that we recommend on Kubernetes is integrated storage. This is a nice side effect in that you can use PV, persistent volumes, right? So it writes the information to this integrated storage mechanism. So that's where you see this Raft enabled true. So those are a couple of defaults.
So there's this question, and I don't know if you know the answer to this question. I don't either, but it says from Paul, it says, is HashiCorp going to have a certified operator for Vault? I think right now the preferred method is with Helm, but is there an operator in the works?
There is not an operator that I know of in the works. If there would be an operator, I know there are a couple community operators out there. A couple of them are for managing and deploying Vault, and others are for managing and deploying Vault configuration. So those are community maintained. I don't know if we're going to certify them, and I don't know if we'll fully support one yet. We are pretty much supporting the Helm chart for now.
Cool. And then I have a question. So you're saying you're using PVs, right? Is this also encrypted at rest, or is that something you have to do on your own?
So it is encrypted at rest. And I'm glad you asked that question because
all right,
there's because this actually gets to the architecture or the interesting architecture of Vault, right? So I deployed Vault. And if I look at the pods. Do you want me to move this
up here?
Probably, yeah, just because our faces are in the way. Yeah, perfect. Thank you. So when I get the pods, you'll notice that there's two Vault pods running. One is the agent injector. As I mentioned before, this is what is detecting for any applications or annotations that need applications with annotations that need a Vault agent. So it will inject it for you. And then there's this Vault 0. This is the Vault server, right? Vault is deployed as a stateful set. So you see this Vault 0, and there's something that's not very promising. It's 0 out of 1 ready. It's a little concerning. And the reason why is that when you first initialize Vault, it is something called sealed. You can think of it, for lack of a better word, you can think of it as the launch codes for something, right? Vault, when you first bring it up, anytime you restart it, anytime something, an outage happens, Vault will come up sealed. So it will seal itself and it encrypts all the data at rest. Now it does encrypt it, at rest anyway, but this is actually like sealing Vault itself. It's like encrypting Vault itself, right? So you cannot access that data. You can't access anything for the Vault config until you unseal it, right? So it's a fail-safe mechanism. If someone decides to restart the thing, they can't just go in and access the secrets. You have to unseal Vault. And this is the infamous unseal process in Vault. It's, as I mentioned, like launch codes. You have to distribute these unsealed keys to various parties, and the different people who have these keys have to come in and issue effectively a Vault operator unseal with the key. So I'll actually go through that process. It sounds very complicated. I will go through this because it is quite complicated, and it's a manual step. You can do it automatically, but there are some security reasons why you would not want to do it automatically. It's called auto unseal.
Oh, okay. So you have to
So
actually execute a command inside the container, looks like.
that's correct. So what I'm doing is I'm running something called Vault operator init. What this does is initialize Vault, the Vault instance. You don't have to run this if you already have Vault data. You only need to run this if you have a new Vault server and a new Vault instance and a new Vault cluster. I am not going to show you my unseal keys because that would be dangerous.
That's
We
right.
are not going to do that. Yes, that would be very bad. You might actually see some of them, but for the most part, I'm saving them into a file. I'm not letting them print out to the screen, so you don't see my unseal keys. But when you look at, let's say, Vault status, yes, I'm going into the container, the Vault server. Yeah, so the sealed is true, right? So this means that I've initialized it, but the Vault instance is completely sealed, so no one can really access it. I can't write anything to it. I can't read anything from it. So what I'm going to do is I'm going to unseal it. And the way you unseal Vault involves a command called Vault operator unseal. When you run Vault operator unseal, it will ask you for an unseal key, in which you shall include that. And when you do, I have pasted it. You can't see it because it was hidden. But when you do that, you'll notice that it says unseal progress 1 out of 3. So you can set up Vault to have any number of unsealed keys you want. If you decide that you want 10 people in your organization to have the keys and 10 people must unseal it, you can configure that. If you want to, the standard is 3 is the threshold. So you must have 3 keys to unlock it. And then you can say, I'll have like 5 total. So this is a little bit like those access codes that you get
you're saying
from like
where they
MFA.
they have to turn the key, right? You have to turn the key at the same time, sort of thing. Everyone has to have a key in order to. Gotcha. So you have to like. So this is the second key.
Yep, this is the second key. And then this is the third key. So once this third key goes in, it will unseal Vault, and that way it decrypts my ability to write and read to that storage, right? To storage. So
yeah, someone says they're like infinity stones, right? You need to collect all of them in order to wield the power of Vault.
Yeah. Exactly. Yeah, it's like you know what? I was laughing because it's the joke that someone said is like, you might as well lock these unsealed keys on paper in a vault or in its actual, like in an actual safe.
In an actual, actual safe,
Yeah, and I was like, I don't know if that's like, some people do that. So now you'll notice that the sealed is false. That means that we've unsealed Vault. The process is called Shamir's secret sharing. So if you want to learn more about that, Vault documentation has plenty of interesting information about the theory behind it. But when you use this as an operator, the idea is that you have to copy those keys, distribute them accordingly. You choose who gets them, how you want to distribute them, how you want to keep them secure. And if Vault goes down, someone has to come in and you have to achieve this threshold, right, of X number of keys before it's unsealed. There is an easier way to do this. It's called auto unseal. I did allude to that before. Auto unseal allows you to effectively store the unsealed keys in a backend of your choice. And something you could do, let's say like Google's key management, AWS key management, you could do a lot of different key management options. And what you'll do is use the key to unseal Vault, right? So when you deploy this on Kubernetes, you can configure it to use auto unseal with the key management backend that you're looking for. The downside is, from a security view, anytime someone restarts the Vault server on the Kubernetes cluster, they can go in and read the secrets. So there are some concerns to that. You may not want to do it for production. You might just do it for development environments, or you might just decide, your security posture allows you to do that, right? You'd rather have the ability to still retrieve. You prioritize availability over availability of the secrets and the applications over, the direct security of the secrets manager. So kind of depends.
Do you find that, you said talking about production, and like in that means that there's other environments. Do you find that organizations just use one Vault system for all their environments, or do they have individual Vault installations? Or so I guess my question is, like, can Vault be multi-tenant in a way where it's like, hey, like, handle many environments, or do you just see people just installing one for each environment?
So it depends on the open source or enterprise version. So the open source version, most of the time I see folks deploying separate Vault clusters, one for development, one for production. I still like that model. I mean, yes, there's it's kind of dependent. There's a cost, right, to running multiple development environments and Vault. But if someone just manages to compromise key, it's reducing your blast radius, right? If someone compromises the secrets or keys in development, they're not going to affect production. You can still evolve them, rotate them, manage them independently. There is a way to do in Vault Enterprise segmentation by something called Vault namespaces. Not the same as Kubernetes namespaces. It's Vault namespaces, but what it will do is isolate certain secrets to certain certain parts of Vault, right? So you can control access control to that as well. And that's kind of, I guess, the equivalent of multi-tenancy. There's also a Vault Federation, so also part of the enterprise set of features is involving replication. So in that situation, you may decide to synchronize multiple Vault clusters because you have a very large secrets management architecture that you want to synchronize. But for the most part, in the open source version, it's probably better to deploy separate Vault clusters for different environments.
Gotcha. And there's actually a couple really good questions coming down. So, I'm actually gonna what I'm gonna do is I'm gonna kind of sanitize this question a little bit, or ask it in two parts. So, usually you talk about Vault with secret management and managing secrets for Kubernetes. Can it also manage things like config maps as well, and not just secrets?
No, it doesn't. It is not a replacement for config maps. You can do it. There's a feature. So the basis of the Kubernetes integration for Vault is a neat, very little, for some reason, not as well known feature called Vault Agent. And Vault Agent is almost like a templating tool. So you could use Vault Agent to template out configuration and then somehow synchronize that to a config map, but that would have to be outside of an existing integration, right? It's not part of the Vault Helm chart. And the secrets portion, Vault doesn't, it is, I guess, a replacement for the secrets, for Kubernetes secrets, for example. Mostly because the way that Vault is treating the secrets, it's mutable. So the general principle is that it avoids writing the secrets in plain text or writing even the secrets encrypted to Vault or to Kubernetes. So that's why you would prioritize Vault Agent. Now, the exception is CSI driver, and that was what I was mentioning before. The trade-off to CSI driver is the CSI driver does write it to a Kubernetes secret, which means that you can see the password and username in plain text. So the result is that it is, if depending on how you run the Vault integration on Kubernetes, it is a direct replacement for Kubernetes secrets. Other times it's not. It's plugging into the API for it.
So so I guess sounds like it depends, right? In terms of, with respect to secrets.
Yeah.
The other question is really great question. I'd like to hear your thoughts about it. Is if someone's on a public cloud, for example, AWS, why would you use something like Vault versus AWS Secret Manager?
Yeah, I get this question a lot. You know, and this is where you have to make this decision from a level of effort point of view, right? AWS Secrets Manager works if you're using AWS, right? If you are using Amazon, something like Amazon ECS, you know, you get it easily integrates with Secrets Manager. You can store secrets there, but the downside is that Secrets Manager doesn't really rotate secrets. For example, it's not going to rotate and handle the issuance of access keys or STS tokens. That's a separate service, right? In Vault, a lot of people favor Vault over the cloud provider's native secrets manager because it works for a lot of different platforms, right? So you can do it with databases, whether it be on-prem, public cloud. Otherwise, you could do it across different public clouds. You can use it to manage from Azure Service Principals to GCP Service Account Keys to AWS Access Keys. You can use it to manage certificates. So Vault is pretty expansive for a lot of use cases, which is why people who are looking to manage their secrets outside of a public cloud, of a single public cloud or a single vendor, really enjoy it as a tool, just because it helps ease some of those workflows across multiple platforms.
Yeah, and here at Red Hat, we're all about the hybrid cloud, right? And that kind of just fits in that whole aspect of just like hybrid cloud and not being kind of tied down, using a platform to kind of move your workloads. And you know, that's and also you know, as you alluded to, and I kind of said before, there's a management system, so like you have to think about rotation as well. There's you know, it's a lot of people talk about like secret management with respect to like encrypting your secrets, or like, you know, having them not visible, but like you also need to like rotate them, right? And that is also a level of effort. You know, remembering to like, you know, rotating database passwords is actually a pretty heavy task, right? Because there's a lot involved in rotating that passwords, you know, from the actual database itself all the way up to the application layer.
Yeah.
And so, you know, having something doing that for you is very important.
Yeah. And I did notice in the chat, Cole pointed out that it can be used for more than secrets management. And that's true. You can use it also to encrypt and decrypt data, for example, data in transit and data at rest too. So there's a lot of things to Vault that you can use. Some people don't, it's not just, a lot of folks don't just use it for storing secrets, although that is something it does help with.
Yeah, that's a big part of it too. It's important.
Yeah, exactly. All right, so I'm not going to run this command because it will show my token. Vault is secured by a token. So now that we've unsealed Vault, we should now be able to store secrets and set up Vault, right? I think that's the natural next step. So what I'll do is actually start setting up Vault by CLI. I just paste this command. I will not run it. This is going into the Vault server, and what I'm going to do is open up a shell so that I can start configuring Vault, some of the Vault components that we'll need. I won't go through every Vault component, but I'll show the two main ones that you're going to need for Kubernetes. The root token is your access key. It's like your password to get into Vault. So thus, I will not show it. I will try my best not to show anything today. That is my goal. But
that is always the goal, right? It's always I've always when you accidentally show your AWS secret key and access key, you're like, well, I guess I need to rotate those now.
Yeah, exactly. That's how I was like, I don't want that anxiety. So,
Yeah.
all right. So I'm in the Vault server. There's something important to recognize about Vault. Vault has two main plugins, right? So if you're familiar with, let's say, Terraform has something like providers. The idea is that Terraform itself is a server, and then there's a client. The client has all the logic. So the providers are the ones that capture everything that you're going to need to do with the target API. Similarly with Vault, Vault has a plugin ecosystem. There's the Vault server. So Vault can store things, it can rotate the secrets, but it doesn't know how to rotate, let's say, a database secret, right? Vault in itself can just give the function, but it can't do anything, right? So every bit of logic that you need to rotate a secret, to manage it, to store it is captured or built into a plugin. And so there's two types of plugins for Vault: authentication methods and secrets managers. We're going to first configure an authentication method. An authentication method is exactly what it sounds like. It's a way for you to authenticate to Vault, right? A token is not a great form of authentication. Sharing the tokens, it's just not very convenient for anybody. If you have lots of different people, like hundreds of people using Vault, you have hundreds of applications using Vault, you don't want to be distributing tokens left and right. So Vault plugins have this layer of abstraction called an authentication method that handles authentication of some identity to Vault. And that will allow that identity to read secrets, right? So that sequence is called an authentication method. Today's authentication method uses the Kubernetes authentication method, which uses the service account JSON Web Tokens. So you can imagine it's very much built into the specific target you're looking for. But we're using a service account JOT to help an application log into Vault, authenticate to Vault.
So does it create that JOT on the fly? So it's essentially, or is that per service account? Does it manage that as well, I guess is the question.
It does not manage the JOT, and that's a great question. It doesn't manage the JOT. It doesn't issue the JOT. It links the JOT to effectively the OIDC authentication flow within Vault.
The provider.
Yeah, exactly. So first thing you're going to do is enable the auth method. Everything you do if you enable an authentication method is Vault auth, enable something. So in this case, I'm enabling an authentication method at Kubernetes. And then what I'll do is I will actually copy this because it's a very long command. But I will create the config for the auth method. Oh, geez. All right. We'll go through this.
It was a really long.
Yes. It was a really long string. By the way, everything is in the repository. I believe it will go in the chat, but is in this repository.
I just dropped it in the chat. So
yay. Excellent. Okay, so first thing is that I need to get the service account token. You can do this outside of Vault. You could use Kubernetes, right? In the case of Kubernetes, you would have to find the right service account that's attached to Vault and then retrieve the token. This is just an easier way to retrieve the direct service account token that Vault server is using. You also need the Kubernetes host, and you also need the certificate authority here. So all of these things need to be added to this Kubernetes config in order for something, in this case Vault, to authenticate from Kubernetes to the Vault server. So some service account must authenticate. The other thing to keep in mind is depending on the Kubernetes cluster you're using, the issuer might change. So definitely check the issuer. That's something to note. I have made that mistake a few times. Okay, so we're going to exit. I've already configured the Vault Kubernetes authentication. So this will allow me to link any kind of service account to Vault, right? It needs a couple of permissions. The Helm chart sets them for you. So that's good. You don't have to do it. But I believe there's a cluster role binding related to token review, but I don't entirely remember. So there are things that you will need to give access to Vault in order for this to work, and it should be all built into the Helm chart. Okay. So that is an authentication method. Should I pause and let's see if there's maybe anyone?
Yeah. There was a question about Vault rotates secrets only, database AWS secrets. What if I need to rotate a token? It's a good question. What if I need to rotate a token?
Yeah.
I guess which specific token? But I guess since it's just a generic management system, I guess you can rotate tokens. I guess would there need to be a plugin for that?
So that's yes. So it would need to have a plugin. So it depends on the token. There is it's called the JOT one is called the Identity Secrets Engine. So if you have JOTs, then it would be the Identity Secrets Engine. For other tokens, like you could say maybe like console tokens, there is a plugin for that. So there must be a plugin in existence in order for Vault to rotate the token. If you can't find the secrets engine, it's likely that there's a generic protocol like OIDC, et cetera, that it may or may not be supporting. So you can also look into that too. But it depends on the token and depends on the target API.
Cool. Let's see here. I don't think there's anything else. Yeah. So I did. For those who missed it, I did post the link to the repo that she's following along. So if you want to take a look at that, it's in the chat.
Yeah. It is I know this is very long and a lot of explanation.
Yeah.
This is our Vault. This is welcome to Vault. So we configured the authentication method. So that way a service account in Kubernetes that we say is okay, like we have to tell Vault, this Kubernetes service account is okay to authenticate to me. So as long as we configure that in Vault, then we don't have every service account in Kubernetes authenticating to it, right? So we have the authentication method configured. The next thing we're going to do is configure a secret. The first secret we're going to configure is the root database token. And this you may accidentally see. So we're going to, I will be very careful on this, but I can't guarantee that I won't accidentally print this out. So Vault has a second type of plugin called a secrets engine. The secrets engine holds the logic for the renewal and revocation of certain credentials. Someone else, usually either HashiCorp developer or the community, will have built this code to handle the renewal of a secret or revocation, right? So they delete the secret or they create a new one. All right, so the first kind of secrets engine we're going to enable is a key value store. This stores a set of keys and it stores values. Oh, response. Oh, yes, that would be you actually. Yes, that would be me. Oopsie daisies. Can you switch to the other terminal? I think.
Yes. Yeah. Oh, there we go. Okay.
So I started Vault port forward. You can set Vault on a load balancer. I just am running this locally, so it's not really helpful. Oh, yes. One moment, please. There is.
You have to export something. Yeah, there we go.
Yes, I have to export the Vault token. So what I don't show you is that you have to export the Vault token and you also have to set the Vault address for the CLI to connect. So just keep that in mind. Oh, no. Here we go. All right. 403. What does it want now?
Well, maybe we can check the... Oh, no, it just says handling. I was wondering if we can check the logs on the...
All right, everybody. Sorry.
Everyone close your eyes.
It's fine. We're destroying this, so...
Okay.
All right, there we go.
Oh, there we
I
go.
don't know why I was all right, I told you one time or another we were going to have it.
Yeah, it was bound to happen.
All right, so the next thing we're going to do is that we've enabled the secrets at expense static. So Vault works on API paths. So what you're going to do is enable them at certain API paths. In this case, I have said I have a key value store at expense static. And what I'll do is I will store a MySQL database login password at expense/static/MySQL. So that's the key and the value. You'll notice they created time. So I've created it, and now I'll get the secret. Yeah, we're here. Here we are. All right. So you'll notice now I'm not just saying that I stored the secret. I have the secret stored. So you'll notice that there's the database login password. So anytime someone needs to get it, they go to this path expense static MySQL. The other thing that you want to do when you start configuring something like this is you want to configure a policy. As I mentioned before, you don't want everybody accessing every secret, right? You want some kind of access control to make sure that no one is going to go and retrieve secrets that they're not supposed to. It's like Kubernetes RBAC. So there is an independent ACL system in Vault that works similarly to Kubernetes RBAC, and it uses effectively API authorization, and it checks for whether or not someone has the policy to, let's say, read, update, create, or delete a secret or a secret path. So you can specify that. So here's a policy. What it will do is allow me read access to the root password that I put into Vault. And then what I'll do is I'll create a Vault policy for that. So it's Vault policy write, and now I've created a Vault policy. What this Vault policy will do is restrict any identity attached to the policy to just the database root password. I won't be able to, let's say, get someone else's password or get some other team's password. I can only access this database password, for example. Okay. And finally, the last thing that we're going to do, because what we're going to do is we're going to create a database on Kubernetes. Gasp. We have this static secret.
Oh, no.
We're going to use the root password to create the database on Kubernetes. So what I'll do is I will do a very, very, very large command. And what this does is bind a service account, the expense database MySQL. This is the service account my database will use in Kubernetes. It binds the namespace, so in this case, expenses, and it adds it and attaches it to the policies. So if you're familiar with most of the cloud providers, you're attaching the policy to an identity. So in this case, my identity is the Kubernetes service account and the namespace. And I'm attaching this policy that only allows me to read the root database password.
And the TTL option, what is that? How long the access is available for? Is that what that is?
Yeah, that's correct. So the authentication flow for Kubernetes is that once a service account authenticates, Vault issues a token. Just like a token, the root token that I accidentally printed out. But the root token, not the root token, the Vault token is there, and it gives a certain period. There's a certain period of time in which that Vault token is valid or available. So it leases, you could say Vault leases that token out to this identity, the expense DB MySQL service account for that period of time. You have to have the service account re-authenticate. So if the service account isn't using that token, right, it's not retrieving any kind of, service, any kind of passwords or credentials, then it just sort of expires and then you have to re-authenticate again, right? But that's usually handled on the side of the Vault client in Kubernetes. For the most part, it kind of just self does this. It's very much automated. But what you'll see as a result is that if someone gets the Vault token, like they exec into a pod and they got this Vault token from the service account, for example, it would expire within the hour.
Gotcha.
Mm-hmm. Yeah. So it's all about ephemeral secrets, which you can see where the mutability starts to become an issue.
Yeah. So exactly. And like, in GitOps, everything is about immutability, right? And so like, this is like kind of like where the contention is. I think this is also where you kind of, I've talked to a lot of people, and actually one of them is Christian Posta. I don't know if you know him from Solo. We were talking, and it's like, it's really the point of demarcation, right? And it really, there's like, and also there's a point of like security practices as well, right? So there is that contention, right, with GitOps, and it's like, where is that? And I always say that if you are, it's the point of demarcation, right? Like, you're not storing pod definitions in a Git repo. You're storing a deployment, right? So like, you're not actually storing every little single piece, right? So like, as long as you're storing some reference that gives you the functionality that you want, I think you're like at the right path, right? At least you're going towards that path of that nirvana of GitOps, right? So so definitely.
And the way I think about it to myself is that the idea behind GitOps was to modularize certain automation pieces of automation in your infrastructure system into different controllers, right? Like the idea is
Mhm.
that you want to separate this. Should you, for something like a secret that's sensitive information, should you be managing it with the same controllers that you're using for deploying an application for something else? And maybe the answer is yes, and most likely the answer is no. It's
Mhm.
managing a different kind of life cycle of that particular infrastructure. Secrets are infrastructure effectively. So it's managing a different part of the infrastructure, in which case, perhaps from a separation of concerns view, it's
Mm,
not
yeah.
really breaking GitOps. It's perhaps just a
Mhm.
different controller or a
Yeah,
different part
yeah.
of GitOps.
Well,
You're
and
deferring that. Yeah.
yeah, exactly. Yeah, yeah. You're delegating that, right? You're
Mhm.
delegating that. I have the same conversation because we're at Red Hat, right? We're all about operators, right? And operators has a lot of automation in it, right? And so it's like, okay, well, where's it's like, well, really, you want, as long as you get a function, as long as your cluster is functionally the same as it was before, right? Let's just say disaster recovery. That does it really matter if it's 100% inside of your Git repo, right? We're talking about Alexis actually from Weaveworks said that like the idea is to have that the cluster is functionally the same, not necessarily exactly the same, right? And so as long as like this database is back up and running, why do you care if the password is the same or not? So it's right, like
Yeah,
that's what I say, right?
yeah.
Do you care if the password is the same, or do you care that their cluster is up and running functionally the
Right.
same? I
Yeah.
think it's the latter, right? So
Yeah, exactly. And it's all about perspective, right?
mhm.
It's invisible. It should be invisible, and then when it
Yeah,
breaks, it's visible, and everybody gets a little concerned.
yeah.
Um, right. So what I did behind it, just because so that it gets a little bit of time to create. I created a MySQL database on Kubernetes, and the reason why I wanted to show this was at least you got the example of a static secret, right? This is something that no one's rotating it. I mean, I guess I could just keep it in Vault and never rotate it,
Mhm.
which you could do. That's static secrets, right? So not every secret has to be rotated, as you pointed out, Christian.
Mhm.
Do you really care if it is or isn't? But from a security perspective, you'll eventually have to rotate it. In this case, what I've done is create the expense database, and it's retrieved the base. It's what it's done is retrieved the database root password from Vault. And the kind of the way you can show. Let me see if I can show this a little bit easier. But you'll notice two pods. One pod is the database, and the other is Vault Agent. So let me see if I can get the logs from Vault Agent. The agent injector created this lovely little snippet, patched it in, and what it allows this to do is to create a sidecar container for Vault. And this Vault agent just runs and renders out some information about the database password. So what Vault agent will do, and this is a bit of the workflow that I do want to show, and I don't know if we can do that. Oh, we won't be able to do that. But what happens is that the sidecar requests the database password from Vault, and then Vault will go to the database and say, "Hey, database, can you create me a new username and password?" And then it will come back and say, "Here you go." That's a more complicated flow, and I'll show that one next. But in this case, it's really just saying the database comes up and says, "Hi, Vault, I need a static password so that I can start myself up." And so then it will start Vault Agent. Vault Agent writes it to a file, and then you can use that file for the application. In this case, MySQL. It's a lot of a back and forth workflow, but it's a lot easier to see it actually in the application itself and not the database. All right. Pause.
So in the as I'm reading this question, we actually already answered this question, right? That you can't really save config maps, but there may be plugins upstream that do that. But my question is you talk a lot about sidecars. Is this kind of like something like service mesh where there's a sidecar in every container, or only on the ones that need it?
This is you can configure it on this. You can configure it to every application. You can.
Uh-huh.
Part of the Vault Helm chart, the agent injector, you can configure the agent injector to inject no matter what, inject by default. By default, however, it will only do it if you have an annotation. So if you, yes, you're
Mhm.
following me. Excellent. So the annotation that is important to include is agent inject true, and that will inject the sidecar. By default, it won't do it unless you add this annotation. It will do it across namespaces as well. The other important sets of annotations, which thank you for reminding me to show the annotations. The other important annotations that you need have to do with Vault config. So remember we created that role that said anyone who's expense DB MySQL can connect to it. Well, this is the role, expense DB MySQL. You also need to set the service account name to match the one that you bound to Vault's authentication method. So remember previously we said if your service account is expense DB MySQL and your namespace expenses, you can authenticate to Kubernetes and authenticate from Kubernetes to Vault and retrieve the static database password. You also need to specify a couple annotations about where you're getting the secret. So in this case, I am getting the secret from the path expense static data MySQL. And this is where Vault agent and configuration kind of mixes a bit. So someone asked the question about whether or not this replaced OpenShift config maps and secrets. This in itself is kind of like configuration, right? So you could, what I've done before is I've rendered a bunch of different configs, static configs, and use the Vault agent template to build it and inject it as a file and pass it to the application. In this case, all I'm doing is exporting the MySQL root password and using some templating commands to retrieve it from Vault. So while this is a little confusing, the idea is that you can template configuration, whether it be for application or for some other target that needs to use this password, and then you can use that to capture whatever config you need.
You know, I'm glad you showed these annotations because it kind of makes me think of two things. Is one, it's like if you're, you know, since this is the deployment, you're actually storing this in Git. And so, you know, this is the important part to store in Git, right? Like how this application retrieves the secret is part of GitOps, right? It'll function, you know, as long as Vault's configured correctly. You know, when I apply this, you know, if the access is configured correctly, when I apply this, it'll have access to that secret, right? And two, so you can technically, let's just say, you know, instead of exporting this, you can technically have written this to a file, right? Because this is just a Golang Go template, right? So I could, and that's technically, you know, your config map settings, even though it's not directly a config map, right? You can write out a configuration if you want. So this is actually really cool.
Yeah. I will show you Christian, you're exactly right, because actually that's the example I have for the application side. This export is because the database, it's a database. So it can't really set the secret. So the hack way to do it, not hack, but like kind of the workaround is to pass some args and source this file. This is actually the file that it's writing to. So it's writing to a file that says export MySQL root password. And so it will source it and then run the entry point for MySQL. What you're mentioning is actually what we're going to show. I'll show this one, but we won't deploy it because of the sake of time. But similarly, right, what you mentioned before was that you could write a configuration. You could write any kind of configuration you need, like a config map. You'll notice this is a Spring application properties file. It's got Zipkin enabled. You know, you've got a data source that connects to expense DB MySQL. You've got the port. The one thing that I've done is render out the database username and password for the application to use to connect to MySQL database, the MySQL database. So it writes it out to application properties. Any kind of config file that you want, you can write it to, and the application can pick up the information it needs from that configuration file.
So we got a question here. This is actually pretty cool. And this was actually a question I had. So when a password are updated or rotated or whatever, when your secrets are rotated, is, you know, I guess the question is, can the deployment be triggered automatically? But I guess the question is it triggered automatically? If not, you know, can we do it?
Yeah, I wish.
Yeah. All right.
Yeah. So it does not get triggered automatically. That's one of the nuances to dynamic secrets. And it doesn't matter if you're doing it on Kubernetes or you're doing it on another platform. your application has to support some kind of hot reload, right? In that once you write out the file, it has to be able to detect that the file has changed and then reload itself, which some frameworks will do it and some frameworks won't, right? So unfortunately, there's not really a way to trigger the application to restart itself after, the secret has been rotated and now it's been rewritten. Vault agent, so the sidecar, will detect and identify changes to the secret. So if Vault says you have to rotate it now, Vault agent will detect that and retrieve and automatically create a new config, render a new config file for you. So Vault agent will automatically do it, but Vault agent isn't able to, poke the application and say, hey, you need to restart because I have a new config file for you. You could write it. It requires a couple of other pieces of automation, but out of the box, if you're doing the agent injector approach, it will not reload the application for you.
Oh, gotcha. It'd be nice to have like a hook, right? Like a sync hook or something.
Yeah.
Like, hey, run this job after you rotate the secrets, and then you can hit your endpoints or whatever to reload the application. Someone asks, and I like to answer it. It says, is Vault better or worse or equivalent to built-in OCP secrets? Well, since OpenShift doesn't have a secret management system, I would say Vault is better. Just because of the fact that it's just OpenShift doesn't have that. OpenShift, you can encrypt your secrets at rest, let me rephrase that. You could encrypt etcd at rest with OpenShift. But like a management system, OpenShift doesn't have any, which is why something like Vault is important to have, especially if you you don't want to do all this stuff manually, right? Like if you don't want to, the biggest thing, right? So some people ask me, how do I treat secrets in GitOps? I say, well, I always say crawl, walk, run, right? The immediate answer is sealed secrets, because the point of entry is so low, right? It's not so steep, but you'll find as you grow, it's really hard to manage, right? It doesn't scale well. When you're at a certain size, you'll need like a management system, and luckily Red Hat has partners like HashiCorp that you can actually get support now on both ends, right? So you have the support for your container platform from Red Hat. You have your secret management support from HashiCorp. So if like supports something, if you're running a large enterprise, something that's really important, you have that end to end. So hopefully that answers the question there.
Yeah, it is. Whatever works, right?
Yeah,
That's what
exactly.
I mentioned, like walk, crawl, run. Crawl, walk, run, right? It's not the Vault is if you haven't noticed, Vault's workflow is quite complex. It's not great when you're first starting and you need to get the secret and you need to just get it running. You have to take the time to and go in and secure it. So it's worth it, but it does have some complexities and you have to figure that out.
Mm-hmm.
And you might not have time to do that. So, all right. So for the sake of time, I'm going to expedite the next configuration a bit. But we configured a static database root password. So now what I'm going to do is configure dynamic credentials. So dynamic credentials work differently than storing it in key value. Key value is here's a key, here's a value. You, the operator or developer, you're going to be the one to figure out if you rotate it. In the case of certain secrets engines will handle the rotation for you. So what I mentioned before was that you could rotate any token you wanted if it was supported by a plugin, right? So these plugins are built with the purpose of revoking and creating new kinds of credentials, and they have a lot of logic in them to do that. So because you don't want to just rotate it and then something breaks. So there's a lot of logic in there.
Yeah, exactly.
So the thing that I've done is you'll see very similar workflow. I enabled the secrets engine at the expense database MySQL path for a database secrets engine. And the database secrets engine has a couple different configs you'll need. You have to tell it which plugin you're going to use. Yes, there are multiple plugins, but they're all bundled under the database type. So there's a plugin for MySQL, PostgreSQL. There's lots of other databases that you can use, but you do have to specify the name of it. And most of them ask you for a connection URL. So Vault needs a way to access the database because it's using a database creation statement to create the user. So you need connection to the database. You also need a username and password with the ability to create and renew users, revoke users, depending on the kind of workflow you want. So this username must be an administrative username and administrative password. Vault can rotate this for you. Fun fact, we will not do that today. But if you pass it in, Vault can handle this internal rotation for you if you tell it to rotate the root password. So you can tell it to do that. There's also the roles. I'm only allowing the expense role. So this is tied to any secrets related to the expense application that I'll deploy. And you'll notice once again, here we are. Root, the root username and the root password. But
I think it's kind of cool that it can revoke itself, right?
Yeah,
it rotates its own access. So that's pretty cool.
Yeah, it's pretty fun. I was like, it's unexpected. And it's very, very nice workflow because you can just say, okay, I'll just rotate my root password because I accidentally printed it out in the connection string.
Yeah. Yeah, that's pretty cool. And then it's almost like hands off, right? Like you got a hands off management for that.
Exactly. The other important piece to take a look at, yeah, there we are. If you can scroll up in the terminal, actually,
that
would help.
All the way.
Sorry, not in the code.
Oh, sorry. Yeah, this guy.
There we go.
Okay.
Yeah, there we are. So you'll notice there's something called a creation statement there. It's kind of truncated by the terminal. But the creation statement is what Vault will use to create a new user. So you'll have to configure something called a role, and that role will tell the database whether or not it should create the user, revoke the user, renew credentials, everything there. So the creation statement is a SQL statement, as you can recognize. So just be sure to get the right SQL statement. And once again, we set our time to live for the database username and password to 1 hour with a maximum of 24 hours. So it gives a little leniency. And then we write, once again, a policy. The policy restricts the expense credentials to only expense. So I'll do a policy there. So I can only read from this path, which contains the database username and password, not the root. This is the dynamic one. So Vault will issue it for me. And so then after that, you'll scroll up. Oh no. Well, anyway, I'll paste this so that way you can see the command. Yeah. But here we go. And once again, we bind the service account. So this will say only expense service account in the expenses namespace can access whatever is defined in this policy. So remember, the policy was expense database MySQL creds read. That's the only one they can access. They can't read the root password that we stored in key value, right? So this means that the expense application can only access one secret, and that would be the username.
Username and password for that application to access the database. Exactly.
Yeah. And it's a dynamic secret. So it is not actually how do I put this? It's not the root database username or password. Vault will actually go to the database, to the MySQL database, and say, hey, can you give me a new username and password? And what you'll see is that it comes out with this unique username and password. I could run it again, and it's a different username and password. Yeah. And so what Vault is doing is it's saying, okay, anytime you read from this API endpoint, I'll issue you a new username and password. I'll lease it to you for a certain period of time, which is an hour. You can opt to renew it, but if you don't renew it, I'll just revoke these credentials from the database, and you can't use them to log in anymore.
So that's pretty cool. So then essentially it's like, oh, I need access to this database. So then as an operator, I can make a policy of anyone that wants to access this database can, do read, for example, right? Like if you want to run a report or something.
Yep.
But you only have access for an hour, and I'll revoke that for you.
Yep, exactly. And if you wanted to do it again, if you still needed access, you have to renew yourself, right? You have to re-authenticate and renew your access. So it's a very useful way to limit the time to live or the life cycle of a given secret. And why this is important to understand, each pod in Kubernetes gets its own username and password. So if that pod, somehow restarts, stops, gets redeployed, Vault issues a new username and password. So if you log into one pod, it's not the same database username and password that you'll find in another one.
In another pod. So like if you have like 10 instances, it'll be 10 different username and passwords.
Yep, exactly. All right, so I know we're coming up on a very long stretch. So what I'll do is I'll move on. You can deploy this with Vault Agent, which is what I originally showed. So agent sidecar was deployed, injected a patch to the deployment, and then you saw that Vault Agent running as a sidecar. There's a second way that I mentioned that you can do this called CSI driver. CSI driver. It's a project that uses the container storage interface, but what it is an interface specific to secrets, to storing secrets. The main difference, however, between this and the Vault Agent is that it does not, CSI does not inject an agent, which means that you don't need hundreds of agents running everywhere.
Yeah.
Instead, all you have to do is deploy a CRD as well as two sets of controllers. One is the CSI secret store driver, which is what I'm updating right now. And then as well as the Vault integration, the Vault driver, so the Vault provider for it. So there's two pieces to this, which I'll show. CTL get pods and Vault. So the big difference, if this will come up today, one of the problems with this is that when you run this on OpenShift, it's not CSI is not recommended. You can, but it's not recommended, and so the result is you actually have to add additional privilege policy to the CSI.
That's always for those who are watching, like anytime you see the word privileged in your SEC, like that's like a big warning, right? Like make sure you know what you're doing, because privileged pod, there's a difference between like a pod running as brute and pod is running as privileged, and like you should avoid privileged unless you absolutely have to, right? So like things for like storage, you kind of have to, right? Because you're like actually accessing the underlying hardware of the node that's currently be running on. So
yeah, and that's where it'll trip you up. You don't really want to. It's not ideal. We can all acknowledge that it's not ideal. But yeah, when you run it as privileged, nothing will get created until you give that access, which I might actually have to uninstall this, unfortunately, in order for it to run. So if anybody has any secrets as to how to get this to, maybe I should just remove all of them.
Yeah, just delete the daemon set, because
let's just rerun Helm, just so it's a little bit faster, because otherwise it will sit here and wait until it has the opportunity. Make CSI. Okay, so let me just CSI deploy. So deploy the driver, and then you have to deploy the Vault provider. Both have to happen. Both have to have elevated access. Your application even needs to have access as well. But I'll show you why the CSI is a little bit different while this deploys. If this doesn't work, then I'll at least be able to show you the manifest. So the CSI driver does not inject an agent. And the reason it doesn't is because it's using a CRD instead. And the CRD that you need to deploy and have available is the secret provider class. So what the secret provider class does is that it uses the secret store driver as well as the Vault provider. It reaches out to Vault and retrieves specific secrets. So remember, in the case of the annotation, I said, let's go out and get the expense database MySQL creds expense. These are the ones that are dynamically issued by Vault. It's the funky username with the funky password. And so similar kind of configuration, I tell the secrets provider class to retrieve it from the API path and then put it as a Kubernetes secret. So this is where it gets a little bit, this is where, Kubernetes secret, the secrets itself, the secret object, it's kind of a decision, right, that you want to make, but it will put them into Kubernetes secrets, which someone can access. It's not
Yeah,
sealed
because
secrets. Yeah.
it's not sealed secret. So like, again, a secret in Kubernetes, it just describes what it is, not what it's doing, right? Like it isn't hiding anything from you. So if you have something in Vault and it's sealed in Vault, but you're injecting that into a secret, well, then that's in clear text, and you just have to keep that in mind, right? You have to keep that in mind when you're using the CSI driver. Yep. I think you're on mute. Is that just me?
I'm on mute. Sorry about that.
Oh, okay. No
Yeah,
worries.
I'm on mute. If you're running a lot of applications and you don't want sidecars, then this could work, but there are some
Yeah.
concerns, right? You do have to have elevated access to the application. You have to have elevated access for the provider and the driver. It does write it as a Kubernetes secret, so let's hope this
Yeah.
works. But
Yeah, and it may not be a big deal, right? So it always it just depends. The the environment, right? Because sometimes production, like it's so separated from development that like only few people can log into it anyway. So this it might work for you in that case, when not a lot of people are accessing the cluster. So
yeah, exactly. All right, so sorry, expenses. So you'll notice that there's a new secret that came up, and it's opaque. Well, I'll just show you.
Yeah.
So there's a new secret that came up, and that's because the secrets provider class is synchronizing the information from Vault to the Kubernetes secret. And well, you get the username and password if you bring up the terminal a bit. But the idea behind this is that if you are using your application and it just needs to read the secrets from it, well, you pretty much have the ability to do this out of the box. If you go check out this one, you'll notice that I can mount the secrets provider class as a volume. And what this will do is allow me to also set this as environment variables. So you can still use the same pattern. You can still use the same approach as what you would expect from a Kubernetes secrets with some additional custom resources.
So it says, so question is, if I have 3 different applications in the same namespace and I want to insert different secrets for each app, then do we need to create 3 service accounts in order to authenticate?
That's a great question. So no, you don't. You can use the same service account as long as you configure, I'll show you the line, as long as you configure your spec to include the service account name that you need. You only need to create the one service account to be able to access Vault. Now, if you have 3 different secrets for each application, from kind of a risk mitigation view, it's probably better to create a service account for each secret and then bind a policy specific to that, right? So say you have expense, a report, and a database, and they all use different kinds of secrets. It's better to just bind different policies to different service accounts and then have them use different service accounts. But there's nothing stopping you from using one service account for all 3 of the applications. You just allow the policy, you expand the policy, right, to allow read access to certain secrets that you need. But keep in mind, like if it would allow expense, for example, to access the root password if you allowed 3 policies to be bound to one service account.
Yeah. It's always risk mitigation, right? It's like, from a technical standpoint, you probably can do a lot of things, but you need to do that risk analysis, right? The risk mitigation, have your the security team also probably needs to sign off on it as well. So it's always to err on the side of caution, right? Right.
Exactly. Well, that is all I had to show. The example is in the repository. I'll build on it for the next part. But hopefully this gives a sense of an introduction to Vault, the couple ways that you can use it on Kubernetes, the different patterns that are offered, and some of the caveats and trade-offs to both. It is a little complicated when you first start out,
Yeah.
but once you set it up and you get the pattern together, it's an easier way to sort of manage and issue credentials that you need to your application.
Yeah, and actually, Florian, I think this is a great question, because I think this segues onto this next episode. So this is a multi-part series, right? And so this first part. So when I first asked, wait, you're on this side. When I first asked Rosemary to come on, she's like, well, I'm gonna need actually, multiple times, because it's kind of a complex situation. So we decided just to do kind of like a baseline Vault introduction this episode. She's actually gonna come next time, right? So part 2. Stay tuned for part 2, where we actually talk about specific implementations with GitOps, and specifically with Argo CD. So that's going to be a fun one. So hold on to your question, Florian. Come, not next week, but the week after, right? Next episode, we'll be on talking specifically about Argo CD and Vault. So that's going to be cool. So thank you everyone for staying on. This one ran a little bit long, but I told Rosemary, hey, we don't have a hard stop, so take as long as you need to have some to at least have the baseline information. I know a lot of people were excited about you coming on, HashiCorp, talking about this with GitOps. So you can find me on Twitter, right? So you'll see down here somewhere where you can find me. Please like, subscribe, all that cool things. And so everyone, take care. And remember, as I always say, if it's not in Git, it's just a rumor. And thank you, everyone. Thank you, everyone, for joining.